Hey y'all, Dr. G here. In this video we're going to explore some algebra when we're dealing with scientific notation. Okay, and as a really quick reminder, with scientific notation we are dealing with numbers like 5.62 times 10 to the 7th, right? And we write numbers out in scientific notation because it provides a convenient way of expressing very large or very small numbers. We're not going to review how to come up with scientific notation in this video. Instead, what I want to do is think about how we can deal with algebra on scientific notation. Specifically when we're dealing with multiplication or division of numbers in scientific notation, or dealing with powers, right? So we raise something in scientific notation to a certain power. Okay? So let's go ahead and start with a more simple number. Something like 4 times 10 to the 6th. Okay, and if we want to multiply this number by an integer, so let's just say we want to multiply it by 5. The thing you need to think about and remember when multiplying numbers in scientific notation is that we ignore the 10 to the power. All we do is work with these two numbers, your multiplication factor and this first number, which I'm going to call the base number. Okay, so to do this, we multiply 4 times 5, and all of this then is times 10 to the power of 6. So the 10 to the power of 6 is not influenced by the value of 5 at all. We finish this algebra out. We have 20 times 10 to the power of 6, or writing it in proper scientific notation, 2.0 times 10 to the 7th. Okay, so overall, this value, this multiplication factor, did impact our power of 10, but not because we multiplied 10 by something. Instead, it's because the number we end up with, our new base number, is greater than 10, meaning we need to adjust our scientific notation representation so it's in proper format where we have one number, then a decimal place, and then digits. Okay? So that's really it for multiplying numbers in scientific notation. Only work with the base number. Let's look at one more example. If we have, let's say, 2.5 times 10 to the 14th, and I want to multiply this by 10. Okay, again, remember all we're working with is the multiplication factor and our base number. So this equals 25 times 10 to the power of 14, or writing it out more correctly, we end up with 2.5 times 10 to the power of 15. Exactly the same idea applies if we are dividing. So let's say we have 4 times 10 to the 6th, and we want to divide this by 2. Okay? Or we could write this out as 4 times 10 to the 6th divided by 2. The same principle applies. We work with the division factor and our base number of 4. So 4 divided by 2 is 2 times 10 to the 6th. This multiplication or division factor does not impact the power of 10 at all unless it impacts scientific notation like we saw up here. Okay? Let's look at one more. What if we have 4 times 10 to the 6th divided by 10? Okay, this is 4 over 10 times 10 to the 6th, right? So the 10 to the 6th is not impacted by our division factor at all, only the 4 is. So 4 over 10 is equal to 0.4 times 10 to the 6th. We want to rewrite this in proper scientific notation, so we want to move this decimal point over to give us 4 times 10 to the 5th. So just like we saw in these two examples, this division does end up impacting our power of 10, but not because we divided by the power of 10 by anything. Instead, it's because it made our base number small enough that we needed to adjust this power to give us proper scientific notation. Okay? So that's how we deal with multiplication and division with scientific notation. Things change a little bit, actually things change substantially when we're dealing with powers, when we're dealing with exponents. Okay, so let's go ahead and go back to our 4 times 10 to the 6th. And let's square this. Okay, if we have 4 times 10 to the 6th squared, what we recognize is that this means 4 times 10 to the 6th times 4 times 10 to the 6th. Okay? So the way to approach this is that to think about this power of 2 being distributed to both the 4 and the times 10 to the 6th. So when we're dealing with powers, when we're dealing with exponents, we need to distribute this into both factors because, as we can clearly see here, it's going to impact both of these factors. Okay, so the way that I encourage you to think about this and maybe even write it out is to deal with them individually. We have 4 squared and we have 10 to the power of 6 squared. 4 squared we know is 16, and 10 to the power of 6 squared, remember we learned that when we take a power of 10 to an exponent, we multiply the exponents. So this ends up being 10 to the power of 12. So our answer is 16 times 10 to the 12th, or if we rewrite this in proper scientific notation, 1.6 times 10 to the 13th. Okay? So everything about this math you've already seen. Okay, you just have to remember the rules when we're dealing with powers of 10 and how that applies to scientific notation.